In section 5.2, we're going to be talking about discrete and continuous domains. Our learning goal, I will graph discrete and continuous data and I will determine whether functions have discrete or continuous domains. So, really the big idea here is just determining the difference between discrete and continuous. So here's what this is going to mean. Discrete is going to be where only specific values are allowed. So only certain numbers. Only specific values in an interval are allowed. So a couple examples of where you're going to run into a discrete situation. If we're talking about like buying tickets to something, buying tickets is discrete because you can only buy a whole number of tickets. You can only buy 1 ticket or 2 tickets or 3 tickets. You can't buy 1.5 tickets or, 2/3 of a ticket. You can't do that sort of thing. So like buying tickets or t-shirts or CDs, all of those situations where you're buying a physical object that can't be split up. And then a continuous domain, or continuous, means that all of the numbers in an interval are allowed. So for example, it's off the page. The temperature outside. If you think about the temperature, if it goes from 5 degrees to 10 degrees, you don't just jump from 5 to 10, or you don't go 5 degrees, 6 degrees, 7 degrees. It actually has to hit every temperature on the way up. Let's think, some other continuous situations. If we're talking about like weight, you can have 4.5 pounds, you can have 4 2/3 pounds. If we're talking about like measurements of that sort where the fractional amounts are allowed, that would typically be a continuous situation. Also, if you just have a totally random function without any situation behind it, then that's usually going to be a continuous situation. So like the linear equations that we talked about are continuous because x could be anything. So that's the main idea behind this, is just determining whether or not we're talking about discrete, so when only specific values are allowed, or when we're talking about continuous, when any number in the interval is allowed. So for our first example, we're given the function y equals 1290x. And this represents the cost, y in dollars. So y is the cost of buying X admission tickets. So X is how many tickets we buy for a museum. Graph the function using a domain of 0, 1, 2, 3, and 4. Is the domain discrete or continuous? And explain. So this is our function that we're given. And when we look at this, let's try and figure out where that 1290 comes from. Well, if we buy 1 ticket, our cost is going to be $12.90. If we buy 2 tickets, our cost is going to be $25.80, or 2 times $12.90. 3 tickets would be $38.70. So this $12.90 is really our cost per ticket. So it's always just good to recognize where the parts of our function come from. So if I wanted to graph this, I would sketch a quick coordinate plane. And because I'm talking about tickets, I can't have a negative number of tickets that I buy, or I'm not going to spend negative money. So I only need to worry about quadrant 1. And I'm graphing using the domain of 0, 1, 2, 3, and 4. So my inputs are 0, 1, 2, 3, and 4. And then let's just count by tens. 10, 20, 30, 40, 50, 60. That should be high enough. So if I buy 0 tickets, my y equals 1290 times 0, or I get y equals 0. That should make sense. If I don't buy any tickets, I don't have to pay any money. So 0, 0 is a point on my graph. If I buy 1 ticket, it's 1290 times 1. So that's going to be about here. That's the point 1, 1290. If I buy 2 tickets, 1290 times 2, that's going to be $25.80. So when I put in 2, I get $25.80, which is about there. If I buy 3 tickets, that's going to cost $38.70. So 10, 20, 30, it's going to be almost 40. And if I buy 4 tickets, I'm going to get $51.60. So 4 is about $51.60. Oops. So if you look at these points, if I did a good job of graphing them, they should line up. And they do, more or less. Obviously, my graph's not perfect. But when I think about this situation and deciding is it discrete or continuous, I can't buy half of a ticket or 2 1/4 tickets. I can only buy 1 ticket, 2 ticket, 3 tickets, 4 tickets. I could maybe buy more, but I can't buy any fraction of a ticket. So I actually don't want to connect these points at all. If I were to connect them, then that would be saying that 1/2 would work, but 1/2 doesn't work. So this is going to be a discrete situation because you can't buy part of a ticket. Okay, let's look at this next example. A cereal bar contains 155 calories. The number C of calories eaten is a function of B, the number of bars eaten. Graph the function. Is the domain discrete or continuous? So one of the things I could do to graph this is I could make an input-output table. Oops. And come up with my ordered pairs that way. So let's think about what I'm putting in and what's going to come out. The number of calories is a function of B, the number of bars eaten. So B is going to be my input. I find out how many bars I ate to tell me C, the number of calories eaten, or the number of calories depends on how many bars I've eaten. So my dependent variable that goes with my output, or my range. My independent variable then is the number of bars that I ate. That'll be my input or my domain. So for this one, it doesn't give me a specific domain. So let's just pick a couple of numbers that make sense. If I don't eat any cereal bars, I don't eat any calories, at least not from cereal bars. If I eat 1 cereal bar, I eat 155 calories. If I eat 2 cereal bars, I'll eat 2 times 155 calories, or 310 calories. If I eat 4, I'm going to eat 465 calories from the cereal bars. And I could keep going and going and going, but that's all we need. So when I graph this, let's do 100, 200, 300, 400, 500, and my input is 1, 2, 3, 4. So if I don't eat any bars, I don't have any calories. There's my 0, 0. If I eat 1, that's 155 calories. If I eat 2, that's 310 calories. 3, oops, I skipped over 3. That's supposed to be 3.
4 bars would then be 620 if I added 155 to that. So 3 bars would be 465. 4 bars is going to be off, but you can see it would be up here somewhere.
So let's think about this situation to decide if it's discrete or continuous. Do I want to connect those dots? And the question you just need to ask yourself is, can I eat half a cereal bar? And you absolutely can. Can I eat a quarter of a cereal bar? Sure, you can. So you could eat fractional amounts, so therefore we can actually connect these points, if I did a good job of making them. Oops. And the graph of our function is actually going to be that entire line, because all of those fractional values in between the full bars are allowed also. So this is going to be a situation that is continuous, because you can eat part of a cereal bar. So just as a final remark, your situation is discrete when you can't have a fractional amount. You can't have a fraction of a person. You can't have a fraction of, like I said, a CD or a t-shirt or a ticket. Those are all discrete situations where you have to get whole amounts. Continuous situations, a lot of times they're going to be measurements, because you can go half a mile, you can go 3/4 of a mile, or you can measure half of an inch, that sort of thing. Temperature, time is usually continuous because time ticks on, you have seconds and minutes and hours. It's not like we just have 1 hour, 2 hour, 3 hours. Things are happening during those hours or during the fractions of the hours. So it's really just looking at the situation that you're given. If you're given specific values, then that's probably going to be a discrete situation. If you're not given specific values, it's more often that you will have a continuous situation. So just keep those things in mind.